And let me bring up the PowerPoint, which is here. So you should be seeing that. So today we're going to talk about switches. I watched one of these videos several months back, and it was interesting that there are some things about switches that you tend to forget. So let's just go through this, and it shouldn't take too long. So, we're going to talk about different types of switches, the arcing noise, and whether you want to, how the switches are designed, and some relays and some special switches. So a switch is a set of electrical contacts that can be opened or closed. So when it's open, it forms an open circuit and there's no load. And when you close the switch, you have a closed circuit and then there's power applied to the load. You can do this mechanically, like here with the finger, or you can use something like a relay, which we'll explain in the next diagram. And if you do a Google search, you'll find if you put in switch, you'll have this thing come up. So it's not a Nintendo switch. It's just an ordinary electrical switch. So basically, a switch is a set of contacts that you can open and close. Here is a typical knife switch that we used to use, in your school days for doing experiments, or some people use these to disconnect their antenna in case there's a storm. You use one of the knife switches. Or what you can do is you can have this switch, the contacts here, and have a coil. And the coil forms an electromagnet when you apply power to it. And the electromagnet pulls this little lever down and causes the contacts to connect. So that's another way of doing it if you want to control a switch remotely. So there's a number of switches. Most of them are mechanical, and these are pieces of metal that move to make the contact. They have moving parts. Forms typically a switch. Now, when you have a relay, you have electrical isolation because the coil is separate from the contacts. You can also get now solid state switches, and there's no moving parts. You can use low voltage to control it, and there is isolation between the input and output. You can some switches are just on a simple IC like this, and then when you get more into the industrial side, you tend to have something like this where you can actually connect some larger wires to it, and this would be a solid state relay. So some of the things that you need to keep in mind when you're deciding what you need to do, one of them is, do you need to switch a full load? So I'll explain that in a second. Make when, noise arcing, DC, AC ratings, type of switches, poles and throws. So we'll look at each one of these. So one of the things you have to look at is, how much voltage do you need to switch? How much current do you need to switch? And how many contacts do you need? And where are you going to be using it? So, you have these small switches, these micro toggle switches, and then you have some of these dip switches that you can use on a PC board. And then you have, other switches designed more for AC switching. And then, you might have a button like this, like an emergency stop button. And depending on the voltages and the current and how many contacts you need, it all determines the size and the cost of your switch. You can also get some of these switches that can be used like in an explosion-proof environment, like for some industrial applications. So again, they'll cost more. You can also get little caps for them that make them watertight. So this all adds to the requirements. Now, one of the things you need to look at is, are you going to switch under full load? So or can I reduce the load before I switch it on and off? So typically, you don't want to really switch under full load because it affects um, the life of the switch, and also you might need a bigger switch if you're going to switch something on the full load. Now, in some cases with power switches and with emergency disconnect switches, like even for 12-volt systems, you have no choice. You want to be able to switch under full load conditions, but ideally you want to reduce the load before you make the switch, turning it on or off. Now, when it comes to amateur radio, you have a lot of antenna switches and switches in ATUs. Um, and they tell you to don't transmit when you're switching, because the full load switching creates voltage spikes that can damage the transistor, and the transistor don't like to go from full load to no load and to full load unless you really design them for that. So for transceivers and transmitters, you don't want to transmit and make the switch at the same time unless you really have to do that. And then you can also, when you first apply power to switches, you can also get some mechanical shock. So, like if you have the old incandescent filament, when you first apply the voltage to it, the filament vibrates a little bit, and that's usually when it breaks, and especially if you turn the lamp on and off a lot of times. And then if you have some transformers and some coils, you can, when you first load them, first turn on the power, you can hear that power going into the transformer. If you were to put your hand on it, you would feel a small vibration. And then the other thing is that some components may appear as a dead short when you first apply voltage to them. So if you have a large capacitor or a motor or some transformers, so the first time, the first few microseconds or milliseconds that the power is going into these components here, it'll appear as a dead short. And if you don't get the right switch, you can actually, when you turn it on, there could be such a load, so that you fuse the contacts together, and then you won't be able to turn the thing off with that switch. So you have to take that into account especially if you're turning on, power to a large capacitor. And there are some devices you can install that prevents a full turn on right away. And for some of these devices, the voltage will ramp up
It'll be good
slowly.
by sleeping there, right? Just going there at night.
So the other thing you have to also take into account is the arcing and the noise of a switch. So switches typically are noisy. So if you have some digital circuits, like microprocessors, you may have to put some dampening, like a capacitor or a gate or something in there, so that it closes quickly. The other thing is when you open up a switch, you generate an arc, and with an AC signal, as the sine wave goes through the 0 point, the arc stops. So this allows you to switch higher AC currents and voltages with a switch. Now with a DC, voltage is always there. So, you have to open up that mechanical contact further to stop the arc, because the DC doesn't go down to zero like the AC voltage does as the sine wave goes through the ground axis. So, typically you'll have a higher rating for an AC current and voltage and a lower rating for a DC voltage and current. So you have to take this into account when you're switching. The other thing is look at your switch life. How often do you have to open and close the contacts? What's the load voltage and the current? Can you turn it down before you switch and then turn it back up again, or do you have to do it on the full load? And then the other question is, if you have to change your switch, how difficult is it going to be? So here, for example, is a rotary switch, and what they've done here is they've also made it with a terminal block here, so if you have to replace this switch, it's relatively easy to do. If you have a lot of contacts and you have to unsolder them, it can be difficult to do that. So you have to keep that in mind too if you have to replace it. And sometimes some of these switches may have mechanical stops to it, and if someone really tries very hard, they may break the switch by just trying to do something that the switch wasn't able to do, like switch into a different position. So there's always a possibility of changing that you'll have to change the switch one of these days. So different types of switches. You have your typical knife switch here on the right side, your push button here, your slide switch. So typically for these, when the contact is closed, you can tell whether it's closed here. If the switch is here on the right, these contacts will be closed. And when you switch it over to the left, these contacts will be closed. Now, if you have a rocker switch like this one over here, or especially with a toggle switch like this one here, it's just the opposite. So if the switch is in this position, the contact further away from the end point of the toggle is closed. So these ones would typically be closed. You flip the switch over this way, this one would be closed. So you have to keep in mind when you're wiring these switches that you wire it the right way. And typically on is up and off is down, but it can vary. And then you have a rotary switch and also a relay. So when it comes to contacts, with the relay, you have a coil, and this coil moves this metal piece up and down. So you can have an isolated set of contacts in the switches. This is typically in push buttons. So, you have a push button here, you have a set of normally open contacts. So this is open. When you push down the push button, it closes. And you can also have like another set of contacts, which are normally closed contacts like this. And, these are separated. So you can run a circuit through here and a circuit through here and keep it isolated. Now, when you have a relay, you typically have a common contact. So this, common goes to here, which is normally closed. You energize the coil. This metal piece moves up, and you have this normally open contact becomes normally closed. So, here you have a common point. So that's another thing to keep in mind. If you have to keep things separated, you may need another set of contacts in your relay. The other thing we need to talk about is poles and throws. So typically you have a single throw and a double throw, and this just means how many contacts do you have. So for a single throw, you just have one set of contacts, so it's either open or closed. And with a double throw, the common is either connected to A or to B, depending on where the switch position is. So this is known as single throw or double throw. So here you typically have just an on-off position. Here with this double throw, it's typically on and on. And then number of poles determines how many of these you actually have. So you can typically have 1, 2, 3, or 4 sets of contacts. You can have more, but typically 1 to 4 is the typical range of what you can buy readily. So this is when you now get into some of the nomenclature. So a single pole, single throw switch is a typical on-off switch. Over here, this would be a double pole, single throw because you have, two poles but only on-off position. And then you can have one over here, single pole, double throw, or double pole double throw, where you have two poles separated, and you can either be connected to here or to here, and then this one can be connected either to here or to here. That's known as a double pole double throw switch. And you can also get them as 3-pole double throw and 4-pole double throw, depending on how many things you need to switch. Typically, these switches are just on and off, and they'll have a little tag saying on or off. These ones will be called on or on. And then sometimes you can get a center position, which is off. So it's on, so it'll be a connection to one of these. When it's in the center position, nothing's connected, so the contact will be in the center here. And then when you move it down, it can be on. Now, some of these ones here can also be monetary contacts. So, you can have like on. So when you toggle it to on, it stays on, but you move it into off, it stays off. And then when you move it up to this one, it only stays up in the on position as you hold it up. And you can also get like a monetary down here too. So you can it just makes contact as you hold the switch. So that's another option you can have. And then here's your typical rotary switch. So all it is a shaft which you turn, and then this little metal piece goes around to the various contacts and makes connection. And you can add more of these switches to it, so you can make any combination you want. Typically it would be like 12 precision 1 pole, 6 precision 2 poles, 4 precision 3 poles, 3 precision 4 poles, and 2 precision 6 poles. These are your typical combinations. The other thing you need to look at is make when. So most of your switches are break before make. So that means that the connection is broken and nothing is connected. So if you look down here in this example, the comet comes in, it's connected to the top. And then as you switch over into the other position, you will reach a point in between the two where nothing is connected. And then when you flip over to the second state, this one is connected to this one here. So you'll have to keep that in mind sometimes. Some electronic circuits may be sensitive when nothing is connected to them and may introduce some noise or some arcing, and it leaves the load or component unconnected between the two switch positions. Now the other thing you can get is what's known as a make before break. So this is, for example, here is, you have a voltage source and a couple of resistors here. So when it's in position A, it's connected to this here, but you don't want to leave this circuit without anything connected to it. So when you move it into this position here, in between A and B, both of them are connected. And then when you move it down into B, you got the 20 ohm resistor connected. So again, it depends on your circuit design, whether you can have two things connected or nothing connected. So that's what you also need to take into account when you're building your circuits. So any questions about switches? So let me just stop the share and stop the recording.